Alright, so we're looking at number 26, negative 9 times the sum of 6m minus 3 plus 6 times the sum of 1 and 4m. So the first step on our notes is said we need to use distributive property. So if the first thing is to use distributive property, I'm going to multiply the negative 9 times the 6 and the negative 9 times the negative 3. And then I'm going to multiply the 6 times the 1 and the 6 times the 4m. So when I do that, I get negative 9 times 6 is going to give me a negative 54m. Negative 9 times negative 3 is going to give me a positive 27. And I have a plus here. 6 times 1 is going to be plus 6. 6 times 4m is going to be plus 24m. So now I have a problem that looks like several of the others. So now I can combine or identify my like terms. So I'm going to draw a line in front of each of my operators so that I can see all my terms. And then I'm going to draw shapes around them so I know which ones are which. So there's my m's, and then this doesn't have an m, that doesn't have an m, but this has an m. So that goes together. And then this doesn't have a variable, and this one doesn't have a variable, and that's a plus 27 there. So then I go back and I'm combining my like terms. You can use a calculator to help you. If you're going to use a calculator to help you with the m's, don't put the variable in the calculator, just put the numbers. Negative 54 plus 24. So then if you have negative 54 plus 24, you're actually going to end up subtracting your numbers. So then we have 0, and we have 30. And it'll be negative because 54 is bigger than 24. So I have negative 30. So we've got negative 30m plus 27 and 6. If I add those together, that's going to give me 33. And then that's our final answer because there's a variable here, but there's no variables here. And then this is what we call a simplified expression. Alright, so now let's do some application problems. This one says to find the area and the perimeter of the above figures. So we're going to first find the area and the perimeter of a rectangle. So to even start this problem, you have to know how do you find area and how do you find perimeter. We remind ourselves that perimeter is just adding all the sides together. And area for a rectangle is going to be base times height. So that's my first formula. Area equals base times height. So in this problem I've got 2w times w. Okay? So if I have 2w times w, well, w times w is going to be squared. Whenever you multiply the same number together, you raise it to a power. So then you end up with 2w squared. And that's our final answer. If I wanted to find the perimeter, I'm going to add all sides. Well, two of my sides aren't shown, but it's a rectangle, so I know if this is w, this is w. And if this is 2w, this is 2w. So to find my perimeter, I'm going to have to add all sides. When I do that, I get 2w plus 2w plus w plus w. And remember, my first rules were to draw lines in front of every operator to help divide my like terms. And that way we don't get confused on which operator goes with which. And then identify your like terms. Well, in this case, everything is a like term. They all have a w raised to no powers. And since I'm not multiplying, I'm adding. We're going to count our w's up. 2w plus 2w is 4w, plus 1w plus one more w is going to be 6w. So the perimeter of the rectangle is 6w, whatever value of w might be. But in this case, I don't solve for w. I don't know what w is. I'm just simplifying the expression. So now let's try our triangle. We're going to start with, this time let's start with perimeter. Okay, so when I do perimeter, I'm going to have 4p plus 8 minus p plus 3p plus 1. Now I could put these in parentheses, but there's no need to because there's nothing being multiplied. And so adding and subtracting in any order, it's all the same. It doesn't matter which order you do it. So I've got let's go back and do all our steps. I'm going to draw lines or jail bars in front of each of my operators to help me identify the terms. I'm going to identify my like terms by drawing shapes around them or highlighting. So I've got a p, I've got another p, and I've got another p, all raised to 1 power. And then I see a number or a constant. And then here's another number or constant with no variables next to them. So I'm going to combine my p's. So I've got 4p minus p plus 3p. Well, I'm going to do this in the easy order. I'm going to add first. 4 plus 3 is 7. 7 minus 1p. Remember, when you just have a p, that's a 1 in front of it. So I've got 4 plus 3 is 7. Minus 1 is going to give me 6. So that means I have 6p. Put that in my dark pencil here so you can see it. Okay. Then we combine our constants. I have 8 plus 1. So that's going to give me 9. That's positive, so I'm going to put plus 9 down here. And that's my final answer, the simplified expression. Now we're going to take this a big step further. It's a little more difficult. We're going to add in some division here. The area formula for the area of a triangle is going to be base times height divided by 2. Okay, so if this is my triangle, there's my base, and there's my height. Okay, so I'm going to add those, I'm going to multiply those together, and then I'm going to divide by 2. So my base is 8 minus p times 4p. So I'm actually going to use distributive property, 4p. Okay, I could have done that up here as well, but it just had w's, so I did the dot. They actually mean exactly the same thing, whether it's the dot or the parentheses, they both mean multiply. Okay, and then all that divided by 2. Well, let's break this down. Let's not worry about the divided by 2 yet. Okay, let's just deal with my distributive property first. So I'm going to distribute the 4p to the 8, and I'm going to distribute the 4p to the negative p. When I do that, I'm going to get 4 times 8 is going to be 32p, and then 4p times a negative 1p is going to be negative 4p squared, because that's p times p. Alright, so that becomes p squared. All that divided by 2. Okay? Now in this case, all you're going to divide is the coefficients. So we're saying instead of having 32p, I'm going to divide that in half. So that's like saying 32 pineapples, and I'm going to divide those 32 pineapples in half. Well, I'm not actually going to cut all 32 pineapples in half. You could do that and end up with 32 halves of pineapples, but you'd have to eat them right away so they didn't go bad. That'd be kind of funny, eating 32 pineapples. Instead, just divide it into 2 groups. Well, if I divide 32 by 2, I'm going to get 16. So I'll end up with 16 whole pineapples, or 16p. Okay? Then here, I'm saying p squared. So instead of that being a pineapple, maybe that's a papaya, because it's p squared. It's a different variable. P and p squared are 2 different ones. It's like saying 32 pineapples and 4 papayas. Who knows? Maybe it's another vegetable, or maybe it's a fruit, or maybe it's a pair of pants. Who knows? Anything you want it to be. Variables are just placeholders. They're values that change. So this p squared, I have 4 of them. So that's like saying I have p squared, p squared, p squared, p squared. I have 4 of them. So I'm going to divide it in 2. Okay. There we go. I divided it into 2 groups. You ask yourself, how many are in each group? Well, there are 2. So that means I've got 2p squared. I've now divided this expression by 2 to get this expression. I didn't do anything to the exponent because that goes with the p. I didn't change it. Okay? This is one of the more complicated problems. Okay? So this is as hard as it's going to get. We're not going to make them any harder than that. All right? If you didn't get everything, make sure you go back and rewatch the video, and don't forget to ask questions in class. All right? Enjoy!